Hello, 7Es, receiving students and teachers. Thank you. You may take your seats. All right, 7Es and receiving students. In today's lesson, we're going to be looking at the link between volume and capacity. All right, 7Es and receiving students. Now, I'd like everyone to look up here to the front. All right, what do I have here in front? All right, a cube or a box. It's not a cube, class. It's a box, or we can say it's a cuboid. All right, receiving students, 7Es, a cuboid. Okay. Now what we're going to do is we're going to find out the capacity of this cuboid. All right, class? We are going to find the capacity of this cuboid, and we're going to do a little experiment. Okay, 7Es and receiving students. Now, we're going to find the capacity of this cuboid by pouring sand, all right, by pouring sand into this cuboid, or this box, small box. So remember, in our previous lesson, we looked at capacity. And who can tell us what capacity is? All right, Kalen?
How much a container can hold?
All right, Kalen said how much a container can hold. Okay, yes, he's correct, but what does he mean by how much? An amount, huh? All right? An amount a container can hold. All right, this is what we're going to do now. 7Es looking up here. Receiving students. All right, like I said, we're going to find the capacity of this box, or this cuboid. Now we've already poured sand into this cuboid. So to find the capacity, I'm going to pour this box, or this cuboid of sand, into this measuring glass. Now who can tell me what do you think the volume will be? All right, firstly, sorry, you don't know because you don't know the volume yet. I haven't given you any information on the volume. So we'll pour this this box full of sand into this measuring glass, or measuring cylinder. Okay, who can give us the volume of this? Okay, we'll have someone close by who can read. All right, Daryl.
$40 milliliters.
All right, he said 40 milliliters. Is he correct? Yes. All right, 40 milliliters of what? Sand. Right, you can say 40 milliliters or 40 cubic centimeters. So we found, what is the capacity of this cuboid, or this box, class? 40 cubic centimeters. All right, 40 cubic centimeters. The capacity, meaning this box, cuboid, can hold an amount of how much? 40 cubic centimeters. All right, now how did we get 40 centimeters? Let's find out. How did we get 40 centimeters? How do we know that this cuboid is 40 cubic centimeters? What are we going to do? Class, does anyone know? Someone please? Samuel?
Length times width times height.
What length times width times height?
Measurement of the box.
Okay, good. So we are going to measure the length, all right, the length of the box, okay, the length of the box, the width of the box, and the height of the box to get the volume. Just to confirm, confirm the capacity. So, okay. Length times width times height, or area of base times height, which is equal to, okay, the length is 5 centimeters. Okay, the length is 5 centimeters, class. Record that one down. All right, the width is 4 centimeters, and the height, okay, the height is 2 centimeters. So what's the volume? What's the volume? Okay, 5 times 4 is 20, 20 times 2 is 40. So 40 cubic centimeters. Okay, 70s and receiving students, do you understand? So we got the volume of the box, and then to find the capacity again, we filled the box or the cuboid with sand, and then to confirm, we poured the sand into the measuring cylinder, and we got the reading 40 milliliters of sand or 40 cubic centimeters. All right, 1 milliliter is equal to how many cubic centimeters, class? 1 milliliter is equal to how many cubic centimeters? You are saying 1,000. 1 milliliter is equal to 1 cubic centimeter. Okay, 1 milliliter is the same amount as 1 cubic centimeter. All right, in today's topic, we are going to be looking at volume and capacity. Like I reminded you, that we're going to look at the relationship of volume and capacity. All right, the link between capacity and volume. Okay, this is just the same. All right. Can I have someone to read, please? Donald, can you read what it says here, please? Donald?
One milliliter is equals to 1 cubic centimeter. 1 milliliter of water takes up the same amount of space as 1 cubic centimeter.
Okay. Good. Next one. Glenda? Can you read, please, Glenda? Okay, Begley, can you help your friend there?
1 liter equals to 1,000 cubic centimeter. 1 liter of water takes up the same amount of space as 1,000 cubic centimeter.
Okay, thank you, Begley. 1 liter is equal to 1,000 cubic centimeters, meaning 1 liter of water takes up the same amount of space as 1,000 cubic centimeters. Okay, so here we are looking at the relationship of volume and capacity. All right, we're going to do a learning activity. Right here I have a tin, okay, with the following dimensions. It has a width of 10 centimeters, a length of 15 centimeters, and a height of 20 centimeters. All right? Have you got that? Now, what you're going to do is, you're going to calculate the volume in cubic centimeters. A, B, how many millimeters is this? And C, how many liters of liquid would the tin hold? So firstly, calculate the volume in cubic centimeters. Okay, B, how many millimeters is this? And C, how many liters of liquid would the tin hold? Okay, remember, you have to get the relationship first of volume and capacity. 1 milliliter is equal to 1 cubic centimeter. 1 liter is equal to 1 All right, 70s and receiving students, we'll go through our activity together. We'll go through our activity together, and the other exercises in your workbooks, receiving students, you can complete that in your own time with your teachers. But we'll just go through this example or this learning activity together. And the other work exercises, you can complete that for your homework. All right. So the tin. All right, so here we have the tin with its different measurements or dimensions. The length is 15 centimeters, the width is 10 centimeters, and the height is 20 centimeters. So firstly, you are to find the volume in cubic centimeters. And remember, the unit is in centimeters, the measurement given, okay? So what is the volume in cubic centimeters, class? One A. All right, volume in cubic centimeters, class? Okay, what are we going to do, our formula? Volume equals length times width times height. Okay, so what is the length? 15 centimeters. The width? 10 centimeters. And the height? So the volume is 3,000 cubic centimeters. All right, receiving students, 3,000 cubic centimeters. Volume must always be in cubic units. Okay, good. Now the next question says, how many millimeters is this? How many millimeters is this? Remember your conversion. 3,000 milliliters. Okay, class? Remember your conversion here. 1 milliliter is equal to 1 cubic centimeter. So if 3,000 cubic centimeters is the same as 3,000 milliliters. Okay, and see how many liters of liquid would the tin hold? 3 liters, huh? All right, how did you get 3 liters? 1 liter is equal to 1,000 cubic centimeters. So, we have to divide 3,000 cubic centimeters divided by 1,000. And then we get 3 liters. So, 3,000 divided by 1,000. Our summary points, just looking at our conversions, volume and capacity conversions. All right. 1 milliliter is equal to 1 cubic centimeter. 1 liter is equal to 1,000 cubic centimeters. All right. Our key phrase for today's lesson, class, could you read, please? Relationship between volume and capacity. And in our next lesson, we're going to be looking at time calculations. But that has brought us to the end of our lesson. Thank you, 7 News and receiving students, for participating.